Right, so this will be our last lecture. We are focusing on inferences now. So we're going to talk about the last inference we have, right, for a hypothesis test. So learning objective, again, for two sample problem, you need to identify the two samples being dependent and independent. And here we're only going to focus on independent samples. Right? We already talked about dependent sample last class. That will be using a pair t-test process. So what if the two samples that you're comparing with are independent from each other? Then we need to use two sample t-test. And two sample t-tests actually have two different processes. That will make it a little bit more complicated. We're only going to focus on one of them, pooled variance t-test. Variance t-test, as long as you know the name of it and you know what it means, and that's good enough. We are not going to go through the process of the variance t-test. So we're only going to focus on pooled variance t-test. Make sure you are comfortable with the process here. The reason that we focus on pooled variance t-test is because the calculation is easier compared to the variance t-test. And then for any hypothesis test, you need to use a 5-step procedure, right? And for all the hypothesis tests, even though I didn't list it here, you need to understand the type 1 error, type 2 errors. Okay. So this is our first animal for the attendance points, giraffes. All right. So compared to the mass pair problem, the two sample t-test is looking at a comparison between two independent samples. For you have two populations. And there are two scenarios for the two independent sample. Where we either have equal amount of variances between the two groups, or we have unequal amount of variances between the two groups. So for example, if you're trying to compare between two populations and they both have normal distribution, all right? So this is your population 1, this is your population 2, and this is your population mean for group 1. This is population mean for group 2. We want to see if the two population means are significantly different from each other, right? In this case, when you look at the amount of the spread between the two populations, they are pretty much similar, right? So in this case, we have equal amount of standard deviations. So we use equal amount variances. Variance is just square of the standard deviation, right? So in this case, we use a procedure called a pooled variance t-test. So if the two population variance are being the same, we use pooled variance t-test. Then on the other hand, if you have two population, this is your population 1, and this is your population 2. And we try to compare the two population mean to see which population mean is bigger or smaller. And in this case, the two population variance or standard deviation will be different now, right? So this is unequal population variances. And for a problem like this, we need to use a process called Welch's t-test. Okay, so that's the two different two sample t-tests we have, either pooled variance t-test and Welch's t-test. So here's another issue. We're not going to talk too much about it. We're saying if we have equal population variance, we use pooled variance t. If we have unequal population variance, we use Welch's t, right? But the problem is, how do we know if the two population variances are being same or different, right? So we really don't know unless we do a test. there will be another hypothesis test. If you understand the hypothesis test procedure, so basically in that hypothesis test, the alternative hypothesis will be population variance of the first group will equal to population variance of the second group, or not equal to, sorry. The alternative hypothesis will be stating there's something being different, right? So the two population variance being different, that's our alternative hypothesis, and the null hypothesis will be the two population variances are being the same, right? And then of course you need to calculate the test statistic, you need to find the p-value, and then based on the p-value compared with alpha, you're either going to reject the null. If that's the case, reject null, then alternative two, you have unequal population variance. And if you fail to reject null based on the p-value and alpha, then we're going to say we have equal variance. Right? And if it is equal variance, we use pooled variance t-test to test the population mean differences. And if it's unequal variances, we use Welch's t-test. So that's basically the full picture of doing two sample t-tests. You always need to have a variance test first before you can do a mean comparison t-test. Okay. But in this class, we're not going to cover this test. So instead, we're only going to focus on the equivariance test. So for all the problem you work with for two independent sample, use pooled variance t-test. Okay? Ignore the other, but you need to know the other one also exists. All right. So then for all hypothesis test procedure, we need to have the 5-step process, right? Stating hypothesis, step 1. Stating rejection rule, step 2. Calculating test statistic and find p-value, step 3. Apply rejection rule and make decision, step 4. And conclusion, interpret the result, is step 5. Out of the 5 steps, only step 3 is different in any hypothesis test. So anytime if you're learning a new hypothesis test from now on, you only need to pay attention to step 3 because all the other steps are pretty much the same. Right? Okay. So for pooled variance t-test, if you just look at step 3, state hypothesis, the hypothesis will be either null hypothesis or alternative hypothesis. So either comparing mu1, you're always comparing mu1 and mu2, right? Null hypothesis, basically mu1 is equal to mu2, but you can write it as mu1 minus mu2 equal to 0 as well. That's equivalent. And alternative hypothesis could be mu1 is greater than mu2, or mu1 is smaller than mu2, or mu1 is different from mu2. You can write it either way, as long as you're consistent with yourself, right? So you're comparing two means. Is one mean bigger or smaller, or simply they're not the same, right? So that's hypothesis. Calculating test statistic and finding p-value, that will be step 3, right? So the test statistic will be calculated as this. This is our calculated t. We're going to use sample mean of the two groups, x1 bar minus x2 bar, divided by, and the SP is a pooled standard deviation. So you're going to combine the two standard deviation of each group together as a common standard deviation. So I pull it together. And the N1 and N2, their sample size of each group. And the pooled standard deviation can be calculated like this. Basically, you're combining the two standard deviations together, right? And then here, you need to know that there's a difference. So for this t statistic calculated for the two independent sample t-tests, the degrees of freedom will be different. That will be n1 plus n2 minus 2. But it's pretty much the same idea as n minus 1, right? Basically, you have two group samples, then it's n1 minus 1 plus n2 minus 1. That will be n1 plus n2 minus 2. Same deal. So everything, after you get a sample statistic for each group, mean standard deviation, the size of the sample, you can calculate standard deviation and you can calculate the t-statistic, right? And after that, the p-value is defined exactly the same way as before, depending on your alternate hypothesis, having different kind of signs, greater than sign, smaller than sign, not equal sign, 2 times probability of t greater than calculated t-statistic value. It's pretty much very similar to, the one sample t p-values expression. And the same idea on the top two, the p-value comes from one side of the t-distribution tails, right? We call those as one-tail test. And then for the bottom one, we have unequal sign. P-value comes from both sides of the t-distribution tails. So we call that a two-tail test. So this is pooled variance t-test. Once you know how to calculate it, the t-statistic and find the p-value, everything else is the same as any other hypothesis test occurred. 5 steps. We're not going to require Welch t-test, but to give you an idea of how it's done, the hypothesis is no different. The hypothesis will be either, the mean of first group is greater than second group, or smaller than, or not equal to, right? The same hypothesis. Then, for calculating the t-statistic in step 3, the formula will be different. The t-statistic here is not too bad to calculate. So x1 bar minus x2 bar divided by square root of x1 squared over n1 plus x2 squared over n2. X bar is mean, s is standard deviation, and is sample size. That's pretty easy. But then when you write your p-value into any of the events here, now before you go to t-table, we need to find the degrees of freedom, right? So this is where it got a little overwhelming. So the degree of freedom calculation is kind of crazy, right? So this is the whole reason that we're not going to talk about Welch's t-test in this class, is because the degree of freedom calculation is overwhelming. But other than that, it's pretty much very similar. Okay. So this is like what we talked about. How do we determine if the variances are equal between the two populations? There needs to be a test being done, right? This test always needs to be done before the pooled variance t-test or Welch's t-test. This test will tell us which procedure to use, right? But we're not going to go through that test because that requires a different distribution that we haven't learned yet. All right. So now let's go through an example, right? So this example, we have a research question. The research question is, someone think that the women will study more than men outside of the class, right? So in this case, they collected some sample. They have 30 women and 30 men selected in a study. And all of them are surveyed about, how much time do you spend to study, after class, right? You have data collected. This is the example I think we have in chapter 1. So we're able to compare the female and male study time using the back-to-back stat plot. So you can see the majority of the female students study between 4 and 6 hours. Majority of the male students study between 1 and 4 hours. So it's pretty obvious that females study more than males in this case, but this is only in a sample, right? So for the sample you collected, women does look like study more than men. But is that significant? Can we infer that to the entire population? So overall, do we have enough evidence that women really study more than men, right? So that's our goal. Okay. So of course, this is going to be a 2 group of samples. You have female as a group, you have male as a group, and they each have some study time for each of the individuals being sampled, right? Then are the 2 groups being dependent or independent? Are there any relationship between the females just selected here and the males just selected here? Will one value affect the other, right? So they're totally different students, right? Then here, they will be independent, right? So if they're independent, we're going to do a 2 sample test, right? And for two sample t-test, we have two options: pooled variance P and Welch's. But we only going to study pooled variance, right? We're not going to focus on, we're not going to touch Welch's T at all. Right, so we're going to need to do a pooled variance T when you look at a problem because we have two independent samples. Okay, so then since we're doing a hypothesis test, we need to go through the 5-step procedure. First step, stating your hypothesis. Okay, so it's pretty obvious. We have two groups. If we use one to represent female and two to represent male, then what's our goal? Our alternative hypothesis will be the claim as claimed as female steady more than males. So you have mu1 represent female, you have mu2 represent male, and obviously this is your claim. So that will be your hypothesis. mu1 is greater than mu2. Then the null hypothesis, mu1 is equal to mu2. So woman steady the same as male. Okay. So next step, state rejection rule. So if P is less than alpha, then reject the null hypothesis. Okay. So if p-value is less than alpha, then reject the null. That's basically your lost this. Yeah. Okay. Sorry about that. Right. So then we need to know if the problem tells us what alpha to use, right? Are we given alpha here? So it didn't give us alpha, but we know the default alpha will be 0.05, right? So don't get, confused. If alpha is not given, we use 0.05 as default. So then we go to step 3, calculate test statistic and find p-value, right? So the test statistic for pooled variance t-test, we need to go back to the formulas we learned. This will be the calculation of t statistic. But in order to calculate this, we need to calculate pooled standard deviation. And then the degree of freedom for this distribution is this, right? So we need all the information here. So let's go ahead and do the calculation. The t statistic as the formula given as x1 bar minus x2 bar divided by SP, and then square root of 1 over n1 and 1 over n2. And then we'll try to plug in numbers. For example, what is x1, what is x2, what is n1, what is n2? So from the problem, we should be able to find mean and standard deviation, right? Once you have data, you can always find the sample mean and sample standard deviation, all the statistics. So suppose we're given the mean and standard deviation here for female 165.2 and 56.5 as this standard deviation for male 117.2 as a mean and standard deviation 74.2, right? So if we write those numbers down, x1 bar is 165.2, x2 bar is 117.2, right? And then total standard deviation, we don't know what it is yet. And N1, we have 30 in there. We have 30 males and 30 females, right? So now we realize we're not able to calculate this unless we find what SP first, right? So now we go to the total standard deviation calculation. It will be a fraction in the square root, and in there is N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared divided by N1 plus N2 minus 2, right? So now we plug in numbers. N1, 30, minus 1, S1, 74.2, right? If you look at the data, take a square, N2, 30, minus 1, S2, standard deviation for males, right? That will be 56.5. Oh, I'm sorry. S1 is 74.2 and S2 is S1 is 56.5 and S2 is 74.2. I got it reversed. Okay. So that will be 56.5. And then this is 74.2. Take a square, right? N1, 30, N2, 30, and minus 2. So I hope you're able to calculate this, in your calculator. It's not too hard. 29 times this plus 29 times this, and the total divided by 58, and then take a square root, right? So if you calculate that out, it will be 65.9. If you have any questions about calculation, you can always, check your math work. You can talk to me. We can talk about the calculation process, but make sure you're familiar with the calculator. A lot of people struggle because they don't know how to handle their calculator. Okay. So then SP is 65.9. We're going to put it in here. So then everything else is good. You're able to calculate the T, right? So the T statistic, if we calculate it correctly, we got 2.821. 2.82. Then step 3 is calculating test statistic and then find p-value. So we need to find p-value now. The test statistics calculated. P-value will depend on your alternative options. As always, you need to look at the sign, right? If the sign has greater than sign, p-value will be probability of t greater than calculated t. And the calculated t is right here, right? So that will be probability of t greater than 2.82. So this is a t event. We need to look up the t table for that probability. So we need to make sure it's consistent with the t table, right? And it is greater than a sign, so it is consistent. We can go to the t table, but don't forget to check the degree of freedom. Otherwise, you don't know which line to check, right? So that's the degree of freedom. Degree of freedom is N1 plus N2 minus 2. 30 plus 30 is 60 minus 2 is 58. Right? So you check 58 degrees of freedom. The closest degree of freedom we can find on the t table is 60. So you check 60 degree of freedom on the t table, 2.82. You have two neighbors corresponding to 2.660 and 2.915. And the corresponding probability for the two neighbors will be 0.005 and 0.0025. Then, the probability of interest, p-value, will be between the two probability of the two neighbors, as we talked about before, right? I like to put in the format of small number on the left, large number on the right, as the normal convention. Right, so step 3 is done. We go to step 4. So now since we find the p-value and we define alpha, we can decide which one's bigger, right? P is a number between 0.0025 and 0.005. Definitely, it's going to be smaller than 0.05, right? So in that case, we need to reject the null based on our rejected null. Right? So the last step, we need to write a conclusion. So basically, just write your result as a sentence, right? If you reject null, that means null is false, alternative true, right? So we have enough evidence that alternative true. So we have enough evidence that this is true, right? So we say we have enough evidence that then we're gonna, write the alternative hypothesis here that the female students study more than males. And this is based on 0.05 significance. Right? So this is for the variance test, the whole process. Our hypothesis test is the same 5-step procedure. Right? When you write a conclusion, you always write a conclusion about the population. Right? You're making inferences to the population. Okay. Right. So you have the same process on the PowerPoint as well, if you want to look at it. So we're always going to assume equal variances for all the problems we're going to encounter to discuss. And even though this is not required, but I'm going to tell you how do you do Welch's t-test. So what if we're saying that the variances are unequal, then that means we need to do a Welch's t-test, right? So this will be Welch's t-test. Then what will be the procedure? This is not required, again, but your hypothesis will be exactly the same, right? Female study more than male, that's the alternative hypothesis. Female study the same as male, that's the null hypothesis. Rejection rule, if P is less than alpha, then reject the null. Always the same sentence. Calculate T statistic, plug in all the numbers of the statistic of each group. You can calculate T statistic here. For the degree of freedom calculation, you can see, if you plug in those numbers, it's pretty overwhelming, right? It's still simple math, basically. It's still algebra. You have add, subtract, multiply, divide, and that's it, right? But it's a little overwhelming. But you're able to find that the degree of freedom is 54.2. So degree of freedom could have decimal places sometimes too. But when you look up the t-table, just approximate it. So 54.2 on the t-table, the closest degree of freedom will be 50. You look at the 50 degree of freedom, this will be the p-value event, and this will be the p-value looked at. And compared to alpha, you reject the null, and then conclusion, we have enough evidence that women study more than men. Again, this is not required. Don't spend any time on Welch's t-test. Okay? All we need to know is we have that Welch's t-test available. Okay? Right, another example. Adolescent obesity is a serious health risk affecting more than 5 million young people in the United States alone. So there are procedures to help. So one procedure is called a laparoscopic adjusted gastric binding. That's a surgery that will have a potential to provide a safe and effective treatment. And then so we have 20 adolescents between 14 and 18 years old with a BMI higher than 35 were selected in the study. 10 of them are randomly selected to undergo a gastric binding, and the other 10 will be assigned to a lifestyle intervention program, which involves diet, exercise, and behavior modification. So all subjects were followed for 2 years after it goes through either of the process. One is surgery, the other is an intervention program. Now their weight loss were reported. And now we need to see if gastric binding is a better solution for adolescent obesity. Basically, is gastric binding more effective? Are you gonna have a bigger weight loss if you go through the gastric binding because it's more expensive, right? Then we have data collected here. Assume we have equivariances for the two groups. So basically, that tells us we need to do a food variance test, right? Basically, the two groups are independent because they're totally different 10 young people, adolescents in each group, right? There's no relationship whatsoever. So one doesn't affect the other, they're independent. Independent will be two sample t-tests, right? Then in our class, I only focus on food variance. It's very sensitive. Right. Okay. So let's go through this real quick. I'm gonna skip on the calculation a bit. Okay. So we have a food variance test to work with. Then the first step is stating hypothesis. We're going to have two procedures. If we use one, represent the gastric binding, and two, represent the intervention. So we basically, the hypothesis will be, we want to know if a gastric binding is more effective. So we have two values to compare, mu1 and mu2. mu1 is average weight loss of gastric binding process people, and mu2 is the average weight loss going through the intervention program. We want to see gastric binding more effective. That means we expect it to have a bigger weight loss, right? So that's our claim. mu1 is greater than mu2. And the null hypothesis is mu1 is equal to mu2, right? So gastric binding is the same effective as intervention program. And step 2, if P is less than alpha, then reject null. So basically, we need to know what alpha value we choose, right? So if you look at a problem, does it tell us what alpha to use? It didn't. But don't worry, we have a default value for alpha, right? The default alpha will be 0.05. And then step 2 is done. And step 3, we need to calculate test statistic and find p-value, right? So test statistic for true sample t will be t-cal. The formula will be given to you on the test. x1 bar minus x2 bar divided by xp times square root of 1 over n1 plus 1 over n2. And then we plug in numbers, right? So if you look at your sample, for gastric binding, you have a bunch of numbers, so you can calculate mean and the standard deviation, right? For gastric binding, you can find the mean and standard deviation, and for intervention program, you can find the mean and the standard deviation, right? So this is basically x1 bar. This is your x2 bar, this is s1, and this is s2, just different notation. You need to, be familiar with your own notation. You don't have to use 1 and 2. You can use like a G and L, just to indicate they're different, right? Okay. So now if we put all these numbers in there, don't forget we have sample size as well, right? What's the sample size if you recall? how many people do we have in each of the group? We have 10 and 10, right? So sample size N1 and N2 are both equal to 10. Then we put in numbers, x1 bar, 21.08, x2 bar, 19.74, and then SP, we haven't calculated yet, N1 is 10, N2 is 10, right? So we need to calculate this. We need to calculate full standard deviation first. So that would be square root of N1 minus 1 S1 squared plus N2 minus 1 S2 squared divided by N1 plus N2 minus 2. So we plug in numbers. N1 is 10 minus 1. S1 is 6.16. Take a square. And N2 minus 1. S2 is 5.06. Take a square. Then you have N1 plus N2 minus 2, right? So you calculate the full standard deviation. I hope you guys, able to do this correctly. Even if you did it wrong, but if you show me the process, you're gonna be fine. Okay. So then the test statistic will be 5.64. No, I'm sorry. The full standard deviation will be 5.64. Right. Then we're gonna calculate the t statistic. This will be 5.64 in here, and we calculate it. Right. Then through the calculation, this will be 0.35. Oh, 0.531. So then we need to find p-value in step 3. The p-value will equal to, depending on your alternative hypothesis, as always, what's the sign in there, right? We have greater than sign. P-value will be probability of t greater than calculated t. And calculated t is right here. So that will be probability of t greater than 0.531. Right? Then we need to look at this probability in the t table. You have greater than sign that's consistent. Then we need to know the degree of freedom. Degree of freedom is N1 plus N2 minus 2 is 10 plus 10, 20 minus 2 is 18, right? So you check on the 18 degree of freedom. You look for 0.531. You can see there's only one neighbor on there, right? The neighbor is 0.68. 0.688, right? And then the corresponding probability for that neighbor is 0.25, right? So you realize your probability will be higher than this, right? Because remember, you have a t distribution, center at 0. This is 0.531. This is 0.688. If you're comparing the right tail probability, the 0.531 will have a bigger area than the other one because it's more, or, you have a cut off a bigger area from 0.531, right? So p-value will be greater than 0.25, right? Then step 3 is done. We find p-value already. We'll go to step 4. So now you know what a p is. You know what alpha is. You just need to make a decision which one is bigger, right? Greater than 0.25, definitely going to be greater than 0.05. So then in that case, we go back to the rejection rule. We're only going to reject the rule if p is less than 0.05, but here it is greater than 0.05. We're not able to reject at all. So we're going to fail to reject at all. And the last step, conclusion, right? So since we failed to reject the null, that we don't have enough evidence. And after that, we write your alternative hypothesis in here, right? that Gaussian binding is more effective. And then this is done based on significance level of 0.5. Okay. So that completes the pooled variance t-test. All right. So then for any decision making we make using the hypothesis test, we always have a chance for either a type 1 error or a type 2 error, right? So what type of error is possible in this case? Excuse me. Since you failed to reject null, that means you have a chance for type 2 error, right? And what does it mean? That means even though we concluded the Gaussian binding is not more effective, but it might actually is, right? So it might be more effective, but we concluded it's not. So we are making a bad decision based on the sample, depending on how you select your sample, right? The sample has to be random. If the sample is not random, then there's already a bias in there. You could get a bad result, right? So this is basically our last inference procedure, pooled variance t-test. And here we have a second animal for the attendance points, bald eagle. Right. So for all different kind of inferences from chapter 14, 15, 18, and 19, we have quite a few different procedures learned. So for confidence interval, we have two different confidence interval, either a Z confidence interval or a T confidence interval for one sample problem. Then for hypothesis test, we have one sample Z test, we have one sample T test, and then we have two samples. We have dependent sample, in which case we need to do a pair t-test, or we have independent sample, then we need to do a pooled variance t-test, right? So here we do a pooled variance t-test in our class only, right? There is another procedure called a Welch's t-test that we didn't require. So overall, we have 6 different procedures. For different problem, you need to make sure you choose the appropriate procedure to solve the problem. And that is actually sometimes the hardest part. So please try to understand each of the process and be able to choose the appropriate procedures for different problem. And that's basically what I hope everyone will be trained, for. So, for example, in the exam, you're gonna have a lot, a few different questions. Then, after you read any open-ended problem, the first thing you need to ask yourself is, which inference procedure do I need to choose? And once you're able to do that, the rest is simple. If it's confidence interval, use the confidence interval process, right? So for one sample Z, X bar plus or minus Z star times sigma over square root of n. If it is one sample T, confidence interval, X bar plus or minus T star times S over square root of n, right? Everything else will be given. Z star will come from Z table with confidence level C% will tell you how to find it. And then T star will come from T table. That will be related to confidence level as well as degrees of freedom, right? And degree of freedom for one sample problem is n-1. The confidence level, default is 95%. Otherwise, just use the confidence level as being provided. And then it's pretty easy. If it is one sample Z test, one sample T test, pair T test, and two sample T test, any hypothesis test need to go through the 5-step process. State hypothesis first step, second step, state rejection rule, third step, calculating test statistic and find p-value. Step 4, apply rejection rule to make a decision. And step 5, conclusion, right? The only step being different between all the tests is the step 3, calculating test statistic and find p-value. So you're going to have a different formula to calculate the different test statistic depending on which scenario you have. All the formulas will be given to you. You just need to identify, what is given in the problem, right? What is x bar? What is mu? What is s? What is n? What is sigma, right? And then you need to find the p-value. The p-value will be a probability from a particular distribution. In our class, we only have either a z distribution for a z test and t distribution, for t test, right? So I need to know how to use z table or t table either way. Okay? And then, it's pretty much the same, right? And for all the hypothesis tests, you have either type 1 error or you have a chance for type 2 error. So make sure you understand the type 1 and type 2 errors. We're never going to be 100% confident about our decisions. We always have a chance for errors. But what we can do is we can control the error rate to be small for both type 1 and type 2 error. So that it doesn't matter what decision we make, we always have a higher chance of making a correct decision than error decision, right? Right. So this is a quick practice, just like imitation of your exam. A question will be given to you. So your first step after read the question will be, what process, what procedure do we need to use in order to solve the problem, right? So for example, a study wants to estimate how much time students will spend to study after school at MSU. There are 50 students randomly selected and asked about the study time at home or in the dorm. Of the 50 students, the average time is 45 minutes with a standard deviation 34 minutes, right? So the keyword, estimation, right? What procedure do we use to do estimations? Confidence interval, right? Hypothesis test is assessing claim being true or false. Estimation is confidence interval, right? Then you look at it, is sigma given? The study time, average study time of the 50 students, that's x bar, right? Standard deviation 34, this is standard deviation of 50 students as well, right? That's s, right? So nowhere is given sigma, then this should be a t confidence interval, right? Because sigma is unknown. And then you follow the process after. Next term, a man aged 40 has a systolic blood pressure of 140, and his doctor tells him that is normal. Though he cannot be convinced, he managed to get a sample of 25 males with similar age with him and find out that average 126 and standard deviation 27. It was told the standard deviation for systolic blood pressure for all men of 40 years old is 25. Can help the man to see whether or not his blood pressure is normal, right? So basically, we're trying to assess, right? We're trying to see something being true or false. So this will be a hypothesis test, right? Then, hypothesis test, we need to do either a z-test or t-test, depending on if sigma is given or not, right? So look at all the numbers. 126, that's mean of the sample, x bar. And then 27, the standard deviation of the sample, that's s. But we're also given 25, right? That will be standard deviation of, you need to realize, all men of 40 years old, that will be the population. That's what the man is interested in, right? So this is actually sigma. When sigma is given, this will be a z-test, right? And then follow the 5-step process after, okay? Next question. A study wants to show whether the firstborn twin will be heavier than the secondborn at birth. And a sample of 11 families are selected for the study, and the twins' weight are recorded as below. So you have firstborn twin and the secondborn twin. We want to see whether or not the firstborn twin will be heavier than the secondborn. So this will be a hypothesis test, right? We're trying to see if something being true or false. It can be answered by yes or no. That's assessment. Then what kind of test do we do? We have 2 groups of samples, right? There will be a 2-sample problem. Then the first question is, are the 2 group samples dependent or independent? In this case, the 2 groups are sampled in pairs, right? they're selecting the twins from the same family, right? So in that case, we have dependent sample. If it's dependent sample, the test we need to do is, we need to do a paired t-test. Then you carry out the paired t-test procedure, right? You define the difference and then perform a one sample t-test on the difference, just like what we did earlier on paired t-test. Okay. Next one, a study wants to estimate the average sleep time for adults. The researcher asked 50 adults about their sleep time. The mean standard deviation is 7.2 hours and 2.6 hours, for that 50 adults. And in the literature, it states the population standard deviation with those sleep time 2.1 hours. Okay. So what kind of procedure do we need to use? Again, look at the keyword, estimation. That means this is a confidence interval, right? Then is it a Z or is it a T? We need to look at what information is given to us. 7.2, that's average of the population, X bar. 2.6, the standard, this is average of the sample, I'm sorry. X bar, and 2.6 will be standard deviation of the sample, that's S. And then this is 2.1, this is population standard deviation, so this is sigma, right? Sigma is given to us, that means we need to do a Z confidence interval, right? And in here, the confidence level is not given to us, but no worry. The default confidence level is 95%, right? So don't get confused if the confidence level or significance level is not given. You have a default, 95% for confidence interval, 5% or 0.05 is for, type 1 error rate alpha, right? Next question, MathSnack is a program designed to help small children to learn math more effectively by playing games on computer, which requires knowledge of math. To evaluate the effectiveness of the program, we have 50 students with similar math background are randomly selected. 25 of them are introduced to the MathSnack games, while the rest stay in their traditional learning environments. After 2 months, a test is given to all 50 students, and the summary is shown as below. So we have two groups. We have MathSnack, we have traditional. We're going to compare, if MathSnack is a better process, right? Then basically, if the MathSnack will have a better score than the traditional teaching environments. Then you have two samples. The first question is, are the two samples dependent or independent? Right? So in this case, you can see that you have totally irrelevant 25 students in each group, right? If they're totally irrelevant, then one will not depend on the other, right? So they are independent. Right? If they're independent, this will be a two-sample t-test, right? And for all two-sample t-tests, we're going to use full variance t-test. So then you carry out the full variance t-test using a FastStack process, right? Next one. This is our class example. Sam pays $740 for his house, and he wants to see if he pays too much. He asks people who live in the neighborhood with similar house sizes, and 10 of the people give him their prices. He's finding out the mean standard deviation of the penthouse on the neighborhood is $650 and $90 respectively, and we conclude that Sam is overpaid. So when you look at the question, we're trying to make assessment, right? We want to see if Sam's overpaying or not. We're assessing that claim. Then this will be a hypothesis test. Apparently, we only have one group of samples, right? You only have that 10 house. That's one sample only. Then it will be between z-test and t-test. Then we look at what are the numbers given to us, right? So then this will be x bar. This will be s, right? And you have sample size n. And that's basically compared with, this is actually mean, right? Then there's nowhere given as sigma. Sigma is unknown, so this has to be a t-test, right? So it's one sample t-test. You can carry out the procedure out, right? So when you learn each individual chapters, it's not as confusing, but when you put everything together now, it's a little bit more challenging, right? So make sure you understand how to choose different process, as well as you need to understand how do you, proceed with each of the process, right? If you truly understand common interval, hypothesis test, as long as one example, the rest is very similar, but there are differences, okay? So this will be it. Let me know if there's any questions, and I'm going to stop right here. Thank you for